Hello lovelies, in this video the brilliant Mr. B is going to be looking at inclined planes for your A-level maths. Now there are lots of examples here worked through at 3 different levels, and you can jump between those levels, check the timestamps to work out where you best fit in and where you need to make progress. Now to go with this, over my website you can get loads and loads of practice papers for immediate download so you can see whether you can do this in an exam situation.
Look at forces on inclined planes. So that's kind of things like blocks sliding down something. And we're going to kind of build up our knowledge step by step here. So we're not going to do a full question all at once. Now the first thing to do is analyse what we have here. So we have our slope, it's a 36-degree slope, and we have a 72 kilogram block on it. Now the question is, find the weight of the block. So you might be thinking, well, the mass is 72 kilograms, so surely the weight is the same thing. And so the weight of the block is going to be 72 kilograms. So there's 2 things here. Firstly, mass and weight are not the same thing. Mass is, you can think of it as all the stuff that makes up the object. Whereas weight, how heavy it is, also involves gravity. So you have to include gravity with weight. So if we say that the mass of an object is 72 kilograms, then the weight, of course, it is going to involve that 72, but we have to include gravity. Now, gravity, we can use the coefficient 9.8 for the coefficient of gravity. Sometimes you use 10 as well, because it's close enough to 10, but 9.8 is a good number to use for gravity. And what that means is, gravity is a force that is equivalent to 9.8 meters per second downwards. And that's acting on everything all over the earth at all times. So to get the weight, we have to multiply by the force of gravity. So we're going to do 72 times 9.8, and that gives us 705.6. Now, what are the units? Obviously, it's not kilograms, because it was 72 kilograms. So we're going to give this away in newtons. So again, remember these 2 things are separate. Mass is how much stuff makes up the object, and then the weight is also dependent on the gravity pulling down on the object. Mass is going to be in kilograms, and the weight is in newtons. So the second thing is it's going to be different units. Now, before we move on, let's just think about what this weight is doing to this diagram. So it's a force that goes downwards, but because it's on an inclined slope, that force isn't going to entirely be downwards. So a lot of that force is going to be redirected down the slope, but not all of it necessarily, because there's also going to be friction, which is the block rubbing against the slope, and that's going to be perpendicular to the force going forwards. So we've got 2 forces. We're going to say we've got a force F and force R. So F is the force moving down the slope, which is likely what we're trying to find. And we can say that's kind of resistance. That's the friction acting on this. However, for this question, the friction is 0. So another thing to introduce is the coefficient of friction, which has this M symbol. And in this, it's going to be 0, which means that it's a totally smooth slope. And so there isn't going to be any resistance. Moving on to the next question, a little bit further here, we want to find the normal reaction force of the block. That's going to be the force that goes in this direction. It is perpendicular to the slope. It's at 90 degrees to the slope. And this is going to be the force where we eventually start looking at things like friction. Although this question itself isn't going to have any friction, but this will come in later. So again, I'm just building this up step by step. Now, the first thing you want to do is you want to work out the weight of the block. So the mass is 30 kilograms. Therefore, the weight is going to be 30 kilograms multiplied by gravity, 9.8. Let's just make a little note of what gravity is at the top, so we remember it. So we're going to do 30 multiplied by 9.8 on a calculator, and that's going to give us 294 newtons. So we know the weight of the block. Now, this is the force acting downwards on the block, like this. And what we want to do here is make some kind of connection between the downward weight and the normal reaction force, which I've labelled in blue and pink. Now, the way to make that relationship is the normal reaction force. We're going to draw it like this, all the way through the block. And then the weight, we're going to draw it all the way down. And what we can do here is we can connect these 2 things up at a right angle. And now we have a right-angled triangle. Now, the next thing to do is think about the angles in this triangle. Now, we have an angle already, and it's for the triangle on the outside, and it's the 69 degrees. Now, with this triangle, we've got the right angle. So that means that the angle at the top must be 21 degrees because all three sides add up to 180. Now, the two triangles together here do make a right angle because the normal reaction force is at a right angle to the slope. So what that means is that these two angles add together to make 90 degrees. So we must have a 69 degrees over here as well. So now we know the angles in our second triangle, and it's going to be 21 degrees at the bottom because, again, it's going to add up to 180. So what is all this about? Why am I looking at this triangle? Well, let's just draw the triangle on its own so this makes a little bit more sense, because I've got quite a lot on the diagram now. So we've got the normal reaction force, we've got the weight, and then we're just joining up the rest of the triangle to make sure it's at a right angle. So what measurements do we have for this triangle? So think about angles. We know we've got the 69 degrees at the top. We know that the blue side, which is a hypotenuse in this triangle, is 294 newtons, because that's the weight going downwards. So let's label that as a hypotenuse. Now we're looking for the normal reaction force, and that's adjacent to the 69 degree angle and the right angle. So that's the adjacent. So you might be able to see we can use trigonometry here. So we need to think about SOHCAHTOA. We've got the adjacent and the hypotenuse. It'll be a car question. Do the form of triangle for car. CAH. And what we're looking for normal reaction force is we're looking for the adjacent. So we don't have that, but we do have the cosine and the hypotenuse, and they're next to each other in a triangle, so we multiply them together. So we're going to do the cos of 69 multiplied by the hypotenuse, which is 294. So we can work that out on a calculator. And that's going to give us, to one decimal place, 105.4. And this is going to be in newtons because it's the force that we were looking for. So what we have here now, this is the normal reaction force. So we can see that R is equal to 105.4 newtons. That's the part of the weight that's actually pressing downwards onto the slope. Now, you might wonder where's the rest of it, because the weight is 294 newtons and the normal reaction force is 105.4 newtons. So where have the rest of the newtons gone? Well, that's what we'll look at next, and that's the force that's pushing the block down the slope. And so if I label that on the diagram, the rest of it is the force that I'm labeling F. So essentially, the weight, which is going straight down, is being split into two forces, the reaction force and the downwards force down the slope, because obviously the block can't go straight down, there's a slope in the way. It's only free to move in the F direction, the direction of the force, so the weight gets split in two. So we'll look at one more example and find the normal reaction force of the block. So again, think about the forces. We're going to have the weight going downwards, but the block can't go straight down. So what's going to happen is that you're going to have the block attempting to go down the slope, which we can label force F. And then we're going to have the reaction to the actual friction as well, which we're going to call R. So to work these out, we went through kind of how we get these in the last question, but now let's just kind of simplify it to the maths that you'll actually be doing. So firstly, the weight. So the weight is simply going to be the mass multiplied by gravity. So that is going to be 60 kilograms multiplied by 9.8. It's always going to be 9.8 for gravity, because I'm assuming every single question you'll be answering is going to take place from Earth. The only time it's going to be different is if a question was set on, say, Mars or Venus with a different coefficient of gravity. If that was to be the case, which is very, very unlikely, I've never seen it, then they would actually give you the number. So we know the weight is 588 newtons. Next, to find the normal reaction force. So to find the normal reaction force, it's the cos of the angle multiplied by the weight, or mass times gravity. So that's going to be the cos of 25 multiplied by 588. That's going to give 532.9 to one decimal place. And that's going to be in newtons. Now, the last one, we've not been asked for this. The question is asking for the normal reaction force of the block, and we have our answer. So 532.9 is our answer. But let's say we wanted to find the force going down the slope. All we have to do, rather than doing cos theta times the weight for the reaction force, it's going to be sine theta times the weight for the force going down the slope. That's going to be the sine of 25 multiplied by 588, and that's going to give 248.5 newtons. Now, looking at these two answers, we can see the force of the weight downwards is 588, and the block can't go downwards, the slope's on the way, so it's split into two forces. It's split into the reaction force, which is the kind of slope holding the block up and pushing against it, and then any friction involved there as well, and that's 532.9. So it's not that much lower than the weight force. And then the forward force is 248.5 newtons. So you can see these don't add up with each other. You can't add F and R together and get W. It doesn't work that way. So don't expect them to be adding up. These are the correct answers. So now the last thing I'm going to do with these is find out how to calculate friction. So in our previous questions, the coefficient of friction has just been 0. So when we calculate the force, you know that's just the force. But with the friction, it's something on top, and it's something that's going to stop the block from moving forward down the slope. So we'll look at find the friction first, and then we'll look at how it interferes, because again, we've got the normal reaction force upwards, which is going from the weight pressing downwards, and we've got the force going down the slope. What the friction is going to do is, it's going to be based off the normal reaction force, but it's going to actually slow down the force down the slope. So let's look at how to calculate it first. So firstly, the weight is going to be the mass times gravity. This is really a variation of force equals mass times acceleration, by the way. And the acceleration is just the force of gravity. And the force we're looking for is the weight. So it's actually using that same equation we've been using before in previous videos. So the weight is equal to 50 multiplied by 9.8, and that's going to give 490 newtons. So now we want the reaction force. So that's going to be the cosine of the angle multiplied by the weight. So if we substitute, that's going to be the cosine of 60 multiplied by 490 newtons. That's going to give 245 newtons. So now, what about friction? So to find the frictional force, this is between the block and the slope, all we need to do is multiply R by the coefficient of friction, which is 0.8. So friction is going to be equal to normal reaction force multiplied by the coefficient of friction. So that's going to be equal to 245 multiplied by 0.8, which is going to give us 196 newtons. And again, there's going to be another step after this where you calculate the force down the slope, which I've labelled in green, and this is going to be taken away from it because it's going to slow the block down. But we're going to move on to that in future questions. Again, we're going to go through this step by step and build up our knowledge. So moving on to our last example like this, we're going to find the weight. The weight is going to be 70 times 9.8, and that's going to give us 686 newtons. Then we're going to find the reaction force, and that's going to be the cosine of the angle, and then that's going to be multiplied by the weight, which is 686. That's going to give us 268.04 to 2 decimal places. So we're not quite finished yet, so let's put our answer to, let's say, 3 decimal places. So 0.42 newtons. We don't want any rounding errors. Then we want the frictional force, and we've got a coefficient of friction. So this is just how rough the surface is. The rougher the surface, the more friction it creates, and so the slower the block is going to be moving because there's less force acting on it. So the friction is going to be equal to the reaction force multiplied by the coefficient of friction, 268.042 multiplied by 0.4, and that's going to give us 107, and to 1 decimal place it's going to be 107.2 newtons. So now we know how to work out the weight. we're going to work out the reaction force, and therefore we can work out the friction. So now onto the medium questions. We're finally going to work through a full question. And what we're going to be aiming for is to find the acceleration of the block, which is going to be related to the downward force down the slope. Now, as usual, we've got the weight and we've got the reaction force. So we're going to start off what we've done in the previous questions. We'll just build in again on one extra step on what we've done before. So we know that the weight is to be equal to the mass multiplied by gravity, and we can type that into a calculator. So 60 multiplied by 9.8 is going to give us 588 newtons. Now, that weight is the force going straight down, and of course the slope's in the way, so it can't go straight down. So we've got the reaction force, which is the slope pushing back against the object, trying to go straight down. And then we've got the force going down the slope as well. Because it's at an angle, that force can split in two directions. Now, there isn't any friction, so there's no reason to look at the reaction force for this. Yes, there's going to be a force pushing back against the object, but it's not going to be affecting the speed if the coefficient of friction is 0. So we're just going to look at the downward force straight away. So that was going to be the sine of the angle, 22 degrees, and then multiplied by the weight, 588. So we can type that into the calculator, and that should give you 220. And then let's have some decimal places here. So what about 269 to 3 decimal places? So we've got the force going down the slope. This is what we covered so far in the last few questions. So what's new? How do we find the acceleration? Well, remember, the force is equal to mass multiplied by the acceleration. So we calculate that the force is 220. We know the mass is 60 kilograms, and that's being multiplied by the acceleration. So what we need to do now is divide that downward force down the slope by 60. And that's going to give us the acceleration. And so dividing both sides of my equation by 60, I'm getting 3.67 to 2 decimal places. So that's going to be the acceleration. At the end, just write the answer nice and neatly. The acceleration is equal to 3.67, and that's going to be meters per second squared. So the big thing to remember here is that if you want to find the reaction force, it's cos of the angle multiplied by the weight. If you want to find the force going down the slope, then that's going to be sine of the angle times the weight. Everything else is just using force equals mass times acceleration. Even the weight is the mass 60 times acceleration 9.8. So let's try this again. So we know we've got the weight of the object is pressing down on the slope. Can't go down through the slope, so the force is going to split in two directions. The slope's going to push back, which is the reaction force, and the block is going to start going down the slope, which is the force going downwards. For this question, we're not interested in the reaction force because the coefficient of friction is 0, so we've got a perfectly smooth slope. So the force of the slope pushing back isn't actually going to affect how fast it's going. So first we're going to find the weight. Force is equal to mass times acceleration. The mass is 30, and the acceleration for weight is always 9.8 because that's the force of gravity. 30 times 9.8 is going to give us 294 newtons. So now for the force going down the slope, that's going to be sine of the angle, 44 degrees for this slope. And that's going to be multiplied by the weight, 294. And that gives us 204 point, let's use some decimal places, don't have any rounding errors. The 3 decimal places, it's going to be 230. Now we've got a value for the force. Force is also equal to mass times acceleration, which is the thing that we're looking for. So the force is 204, the mass is 30, and the acceleration is what we're looking for. So divide both sides by 30. And that's going to give us, with 204 divided by 30, it's going to be 6.81 to 2 decimal places for the acceleration. Then at the end, just write out the answer nice and neat with the units. So the acceleration is 6.81 meters per second squared. So let's do one more question. This time the slope's pointing in the opposite direction, but it's not going to affect our maths. So we've still got the weight pointing downwards. We've got the reaction of the slope pushing back, and then the force going down the slope. We don't care about the reaction force because there is no friction on this slope. So we're going to find the weight. The weight will be equal to the mass 70 multiplied by the acceleration gravity, which is 9.8. So 70 times 9.8 is going to give us 686 newtons. Now we want the force going down the slope. That's going to be sine of the angle. This slope is a 50-degree angle. Multiply that by the weight, and that's going to give us 525. And then we want decimal places. Let's say 506 for the decimal places. So just going to 3 decimal places from the answer. So now we want the acceleration. Force is equal to mass times acceleration, and we have the force. It's 525. The mass is 70. So to find the acceleration, we're going to divide both sides by 70. And our 525 number divided by 70, including decimal places as well, is going to give us 7.51 to 2 decimal places. So again, at the end, write the answer with the units. 7.51 meters per second squared. Now, if you're wondering why the units meters per second squared when there's no meters or seconds to be found in the entire question, the reason for that is because right at the start, the 9.8 for gravity, that's the measurement of gravity in meters per second squared. So we've actually used meters and seconds in this calculation right at the start with that 9.8. So for the next question, as usual, just keep in mind in all the different forces on the slope. So we've got the weight going downwards. We've got the reaction force, and we've got the force going down the slope. So we're going to start off like we normally do. So we're going to try and find the weight. So the weight is going to be equal to the mass multiplied by the acceleration, 9.8 for gravity. So the weight of the object is going to be 588 newtons. Now, we're being told that this is a smooth slope. That means that we don't have any friction, so we don't need to worry about R yet. We'll move on to that for the hard questions. So let's think about the force. So the force is going to be equal to the sine of the angle multiplied by the weight. So looking back at what I've written here, we know the weight, 588. We don't know the angle of the slope. And actually, the question is asking for that. It's asking for the slope's angle of incline. This information is missing. So our objective is going to be trying to find that angle. So we can't progress any further with this calculation. All we can say is that the force is equal to 588 lots of sine theta. So what else can we do? Well, again, think about what your next step would have been. So what you would have done is you would have said, well, force is equal to mass times acceleration. We know what the force is. We've got something for it. We've got 588 sine theta. So we can substitute that in. And we know the mass. The mass is 60 kilograms. And because this is a reverse question, we've actually been given the acceleration. We've been given the answer. And it's 6.43. So we can actually proceed with our calculation here. We can do 60 multiplied by 6.43. And that's going to give us 385.8. So 588 sine theta is going to be equal to 385.8. And so what we have here is an equation. And we want to make theta be the object of the equation so we can figure out what theta is. So what I'm trying to show you here is that if it is a reverse question, and you've got to kind of find part of the question you usually have, if you just work through the usual steps you do, and then just leave the thing you're looking for as a variable, in this case theta, then you're likely to get something at the end that you can solve to get what you want. So how are we going to solve this? So we've got sine theta. To get sine theta on its own, we divide both sides by 588. And if we do that, we're going to get that sine theta is equal to 0.65612 to 5 decimal places. But we don't want sine theta. We want theta on its own. We want the angle on its own. And so our next step is we need to do inverse sine to both sides to get rid of the sine. And if we do that, then you should get 41 degrees. It's actually 41.0048, but to one decimal place, it's still 41 degrees. Even to two decimal places, it will be 41 degrees. So we'll go with 41. So let's try another question like that. So the block is resting down on the slope. It's got a weight. The slope is pushing back against the block, the reaction force. And this, again, is a smooth slope, so the reaction force isn't going to come into our calculation, but it will do for our next few questions. And then the object's going to start going down the slope. It's like all the energy from the weight is being distributed in two directions, the reaction force and the force going down the slope. The reaction force stops it from falling through the slope, so it's being held up on the surface of the slope, and then the force is the speed of this slope, the block going down the slope. Now, again, we know this is a reverse question because it's given us the acceleration. We're actually looking for the slope's angle of incline again. But we're just going to go through the steps we'd normally go through for this question, assuming we're trying to find the acceleration. So we'd say the weight is equal to 90 multiplied by 9.8, the mass multiplied by gravity, and that would give 882 newtons. Then we'd find the force going down the slope. So that would be the sine of the angle, which we don't know, so we'll leave it as a variable, multiplied by the weight. And so all we can do here really is just use algebra rules and say it's 882 sine theta. So in algebra, you just put any numbers at the front as a coefficient, rather than leaving a multiply 882 in place. So next, we also know the force is equal to the mass times acceleration. So the force, 882 sine theta, is going to be equal to 90 kilograms, the mass, multiplied by 4.30, the acceleration. We can do 90 multiplied by 4.30, and it's going to give us 387. So we've got 882 lots of sine theta is equal to 387. So now we need to solve the equation. Divide both sides by 882, and that'll give us that sine theta is equal to 0.43878 to 5 decimal places. Just using plenty of decimal places here, so don't have any rounding errors. Then we'll do the inverse sine to both sides to get theta on its own, and that's going to give us 26.025 degrees. So even to one decimal place, this is going to be 26 degrees. So again, one last reminder, if you're doing a reverse question, just do the normal process you would find. And what should happen is that you can't do part of the equation because that number's missing, but you keep it as a variable, and you end up at the end with an equation you can solve. Moving on to the hard questions. So again, we've got a block on the slope. It has a weight pushing down the slope. It has a reaction force, and this time we actually have a coefficient of friction, which is 0.4. So we do need to be looking at the reaction force here, because then the force going down the slope is going to be altered by the friction. It's going to slow it down. So let's go through our usual steps. The weight is equal to the mass times the acceleration. That's 40 times 0.8. 40 is the mass of the block, 40 kilograms, and 9.8 is the coefficient of gravity on Earth, which is 392 newtons altogether. Next, we need to find the reaction force because we need to figure out the friction. And remember, this was because of the angle of the slope multiplied by the weight. So the total reaction force is going to be cos 29 multiplied by 392. And that's going to give us 342.851 newtons to 3 decimal places. So now we're going to use this to find the friction. So the friction is going to be equal to that reaction force multiplied by the coefficient of friction, which is 0.4. So that's going to give us 139 or 37.140 newtons to 3 decimal places. So now we know what the friction is going to be. So we'll come back to the friction later. So next we'll look at the force. Now remember, this is sine of the angle. So sine of 29 multiplied by the weight, 392. And that's going to give us 190.045 to 3 decimal places. So now we're going to be looking at force is equal to mass times acceleration to find the acceleration of the block. However, with the force, we now know the friction, and the friction is going in the opposite direction to the force. So when we're looking at force is equal to mass times acceleration, we have our force 190.045 newtons, but we need to take friction away from it. So we're taking away the 137.140. And then that's what's going to be equal to the mass times acceleration, 40 times A. So firstly, let's take away our two forces away from each other. And that should leave us with 52.905 newtons. So that's equal to 40 lots of the acceleration. So now we solve the equation. We can divide both sides by 40, and that's going to give us 1.32 to 2 decimal places for the acceleration. So we'll just finish off by writing down our answer with the units. The acceleration is 1.32 meters per second squared. So the big change here is that we do have to calculate the normal reaction force. We have to multiply it by the coefficient of friction to get a value for the friction, and then we take that away from the force going down the slope at the end. So let's try a few more examples. And again, identify the different forces. We've got the weight, the force of the block going down the slope, the reaction force of the slope pushing back against the weight so the block doesn't fall through, and we have a coefficient of friction 0.5. So let's find all these forces. The weight is equal to 50 kilograms multiplied by 9.8 meters per second squared of gravity, and that gives us 490 newtons. The reaction force is the cosine of the angle of the slope multiplied by the weight, and that's going to give us 266.873 newtons. So now we want the friction, which is going to be that force multiplied by the coefficient of friction 0.5. That's going to give us 133.437 to 3 decimal places. Then we find the force going down the slope. That's going to be the sine of the angle multiplied by the weight. Do the same calculation as reaction force, just sine instead of cos. And that's going to give us 410.949 to 3 decimal places. So now to find the acceleration, force is equal to mass times acceleration. We have our force. The force is being held back by friction, and that's equal to mass times acceleration. So we're going to work out the total force by subtracting them away from each other. That's going to be 277.512 to 3 decimal places, and that's equal to 50 lots of the acceleration. So we need to divide by 50 to get 1 lot of the acceleration. That's going to be 5.55. So our final answer is going to be 5.55 meters per second squared. So let's look at one more example like this. Again, identify forces, the weight of the object, the slope pushing back, and the friction, which means it's going to slow down the force of the object going down the slope. So the weight is going to be equal to 70 multiplied by 9.8, and that's 686 newtons. The reaction force of the slope pushing back against the object is going to be the cosine of the slope multiplied by the weight. And then to find the friction, which is what we're really looking for, we could combine this into one step. Let's make clear this is the friction. Always going to be multiplying this by the coefficient of friction 0.9. So you can do this in one step if you're confident, like I'm doing here, or you can keep doing it in 2 steps, like I've done with the previous examples. So it's just an option that you have. That's going to give 554.915 newtons of friction. Next, we're going to find the force of the object going down the slope. That's going to be the sine of the angle 26 multiplied by the weight. And that's going to give us 300.9 0.723 newtons. So now we do our force is equal to mass times acceleration. So our force going down the slope is 300.723. The friction pushing back against it is 554.915, and that's equal to the mass 70 times acceleration. Now, this is going to be quite interesting because we take away the number of newtons of the friction, we're actually going to get a negative number. We get negative 254.192, which equals 70 lots of the acceleration. So we divide that by 70 to get the acceleration. We're actually getting negative 3.63 to decimal places. So how can we have a negative acceleration? Well, don't get acceleration speed mixed up. It doesn't mean it's going backwards. It's not going to be flying back up the slope in the direction of the friction. That's not going to happen. What it means is that every second it's going to slow down by 3.63 meters per second. So actually the friction is making the object slow down. Now, if you go back to what the question's saying, the question says the object is released from rest. That means that its speed is at 0. So what happens if an object has a speed of 0 and the acceleration is negative? Well, all it means is it's not going to be moving. It's going to stay still. So what this means is with an acceleration, let's just write it down with the units. With an acceleration of negative 3.63 meters per second squared, it just means that this object is not going to move because the object is not heavy enough to generate enough force to move past the friction. And a coefficient of friction of 0.9 is really large. So don't be surprised if sometimes the objects are not going to move. Now, for the next question, we're going to start off the same way. So we're going to find the weight, we're going to find the reaction force, which is going to be multiplied by the coefficient of friction. And then we're going to find the force going down the slope and then the acceleration. So let's try and do that. So the weight is going to be equal to 60 multiplied by 9.8. And that's going to give us 588. The reaction force is going to be equal to the cosine of the angle 34 multiplied by the weight, and that's going to be 487.474 to 3 decimal places. So now we're going to use that to find the coefficient to find the friction. So friction is going to be equal to that force multiplied by the coefficient of friction, and the problem here is we haven't been given it. And on top of that, we're actually being asked in the question to find the coefficient of friction. So we're going to have to leave that as just an M, as algebra. So let's just move on and carry on with the rest of the steps. And of course, there'll be a point where we have to stop again because we've got this algebra getting involved. So the force going down the slope is going to be sine 34 multiplied by 588. So that's going to give us a force of 328.805 to 3 decimal places. So now we're going to do our force equals mass times acceleration. So our force is 328.805. Take away the force of the friction, which is 487.474 N, because we haven't actually worked out the total friction. That's going to be equal to the mass times acceleration, which is 60 multiplied by acceleration. We've been given this 3.04. So we can do 60 multiplied by 3.04. That's going to give us 182.4. On the other side, we can't actually take these away yet because we have that number m involved, the coefficient of friction. So what can we do to solve the equation? Well, we can take away from both sides the 328.805, and that's going to leave us with a negative 487.474, and it's going to give us a negative 146.405. So now, to get the coefficient of friction on its own, we need to divide both sides by negative 487.474, and if we do that, we're going to get 0.3. So we've got the coefficient of friction at 0.3. And that's what we're asked to find. So again, when you get a reverse question, no matter which bit of the question you're looking for, go through the question like you normally would. If you get to a bit that you don't know, like in this case, the coefficient of friction, just use an algebra letter to represent it. Carry on with the question, and at the end, you're going to have an equation that you can solve to find what you need. So let's do that one more time. So again, identify the forces, so you know what you're working with. We've got the weight, we've got the reaction force, which will give us a friction, and we've got the force going down the slope. So find each force. The weight is equal to 40 times 9.8, and that's going to give us 392 newtons. The reaction force is going to be the cosine of the angle multiplied by the weight, and that's going to give us 349.275 to 3 decimal places. Now I want to get the friction, which is the reaction force multiplied by the coefficient of friction, which we haven't been given. So again, we're going to keep that as a variable, and then we'll have an equation at the end we can solve. The force going down the slope is going to be the sine of 27 multiplied by 392, and that's going to give us 177.964 newtons to 3 decimal places. So now I want to do force is equal to mass times acceleration. Our force is 177.964. We've taken away the friction, which is 349.27 m, and that's equal to the mass 40 times acceleration, negative 0.66. So the negative acceleration, this object is not going to be moving, but we need to know what kind of friction is causing that to happen, because if you did want it to move, then you're going to need less friction. So we can start to solve the equation. Let's collect up terms we can collect up. So 40 multiplied by negative 1.66 is going to give us negative 66.4, but the left-hand side is not going to change. So now we can take away from both sides 177.964. That's going to give us negative 349.275 of the friction is going to equal negative 244.364 on the other side. Then we can divide both sides by the negative 349 number, and that's going to give us, for the coefficient of friction, 0.7 to 1 decimal place. So what you might be thinking here is, if you're happy that the object should not be moving on this slope, then you know that set 0.7 is a good coefficient of friction to use. And maybe you can go down a little bit lower. You can use trial and error for that. If you do want it to move, this is telling you that 0.7 is too much. You might want to try 0.6 or 0.5 so the object does actually start to move.